All right, we're going to move on to section 11.4 today. We're going to work on something called indirect proof. I know what could be better than logic and proof. We've done several chapters on direct proof, and this is indirect proof. So it's exciting. This is just an extra blank, so we're just going to nix that. What is contradiction? So we say two statements contradict when they both can't be true at the same time. Two statements contradict when they both can't be true at the same time. So to say something like today is Monday, today is Friday, they can't be Monday and Friday at the same time. What is the law of indirect reasoning? If valid reasoning from a statement P leads to a false conclusion, then P is false. So you start out with a statement, you use logic, definitions, theorems, postulates, etc., properties. And if doing so takes you to a false conclusion, then your original statement must be false. That's indirect reasoning. So here I have steps for writing indirect proof. Number one, assume the opposite of what you want to prove is true. Number two, reason correctly. Just trying to get this a little bit bigger. There's that better. Reason correctly from the given information until a contradiction of a known postulate, theorem, or given fact is reached. State that what was assumed to be true in step two is false. Hence, it follows that one of the other possibilities is true. And four, eventually the one remaining possibility is the desired conclusion. In the case where there are only two possibilities, our proof is complete. So here are the steps we're going to be following. And yeah, so what is an indirect proof? It's this idea here, right? So you're going to kind of like before, you're going to state the given. So state what is to be proved. Assume the negation use theorems, postulates, properties, etc. to logically come to a false conclusion or contradiction. show what was to be proven must be true. So this is going to sound really complicated and messed up. So obviously we need to look at an example. So write indirect proof argument to show that no triangle has two obtuse angles. All right. Hard to draw a picture because it doesn't exist. So we're going to show that via an indirect proof. So we'll say we are given a triangle ABC such that it has two obtuse angles. So what I'm doing here is we want to prove that no triangle has two obtuse angles. So we're going to assume that it does, such that it has two obtuse angles. So there's your you're stating the negation or the opposite instead of like a direct proof where you would say we have a triangle. We're going to instead of trying to show using postulates and theorems directly that no triangle has two obtuse angles, we're going to assume there exists a triangle that has two obtuse angles and then show from a contradiction why that can't exist. So we are given a triangle ABC such that it has two obtuse angles. So let's say the measure of angle A is greater than 90 and the measure of angle B, is greater than 90 degrees. So then we're going to say, by the triangle sum theorem, measure of angle A plus the measure of angle B plus the measure of angle C must equal 180 degrees, right? In our case, measure of angle A plus the measure of angle B plus the measure of angle C is going to be greater than 180, okay? Because these two angles are more than 90. That's what the definition of obtuse is, right? So we could say that, let's say measure of angle A is bigger than 90 and B is greater than, I probably should say by the definition of obtuse angles. That'd probably be more thorough. That's why I left the space over here, so you can add. So then by the triangle sum theorem, angles have to add to 180. In our case, our three angles are going to be more than 180. This is a contradiction. So our three angles can't add to exactly 180 and add to more than 180 at the same time, right? Back here, we define the contradiction as being when two statements contradict when they both can't be true at the same time. These three angles can't both add to 180 and be more than 180 at the same time. So we stated the given. I kind of maybe wasn't so thorough up here. We should have maybe said we're given triangle ABC, and then we should have said maybe we will show this part here. So we will show that no triangle has two obtuse angles, using a proof of contradiction. So sometimes indirect proof is called a proof by contradiction, or proof, I guess by contradiction. Sorry, I could have done that better. Hopefully you're kind of getting the idea. So we got to this part. We had our triangle sum theorem says this. Our actual case is this. This is a contradiction. Therefore, our assumption, which was triangle ABC, has two obtuse angles, right? We assume that up here, such that it has two obtuse angles. So therefore, our assumption must be false. And thus we have shown no triangle can have two obtuse angles. So that was kind of a clumsy attempt on my part. All the information's here. I just could have done it a bit better. So good thing there's another example. What you could do here is you could hit pause, maybe on a separate sheet of paper. You give this one a whirl. Try it yourself. Better to try and fail than not try at all, right? But if you were to kind of give it a try, and even if you messed it up, it would be better for you to try instead of just watching me do it. But I'm not there, so I don't know what you're going to do. All right, given triangle ABC with D on AC, but not at the midpoint. Prove that triangle ABD is not congruent to triangle CBD. So write the given. Given triangle ABC with D on AC, but not the midpoint. We will show ABD, triangle ABD is not congruent to triangle CBD using proof by contradiction. So we're going to assume the opposite of what we're going to prove is true. So assume triangle ABC is congruent to triangle CBD. Okay? So that's what we're assuming. So we say since triangle ABD is congruent to triangle CBD, AD equals DC by CPCF. Right? Because if these two triangles are congruent, then all their parts have to be congruent, which means that CD must be the same as AD. Then D is the midpoint of AC by definition, because the definition of midpoint says that D has to be on AC such that AD is DC, and that's what we have. So D must be the midpoint, but this is our contradiction. This is our contradiction because we are given D is not the midpoint of AC. So we showed that if the triangles were congruent, then D would be the midpoint, but we're given it's not the midpoint. So that's a contradiction, right? Because D can't both be the midpoint and not the midpoint at the same time. So our assumption, which was that the two triangles are congruent, so our assumption is false. So just like we did up here, so we are say our assumption is false, and thus we have shown that triangle ABD is not congruent to triangle CBD. So that's kind of the logic, right? We say, prove that these two things aren't congruent. Well, let's assume that they are congruent. What would that mean? Well, that's going to take us to that D is the midpoint. But D can't be the midpoint because that's what we're told in the given. That means our assumption's false, which must mean that these two triangles cannot be congruent. That's a proof by contradiction. Okay, so your homework then is right here. So give that a whirl and see how you do.